All right, everybody, welcome back. I'm so excited for this deep dive because we're talking about something that affects every single one of us every single day.
Definitely. It's one of those things we kind of take for granted, but
We just expect it to work.
right.
And when it doesn't work,
Oh, yeah.
it's
It's a problem.
it's a big deal.
Yeah.
Like this morning, my wifey was down and I couldn't get my
Oh,
coffee.
the horror. It was
I can't even imagine.
tragic.
Yeah.
But really, today we're diving into the world of networks.
Yes.
And I'm so excited to have you here to help us unpack all this stuff.
Well, thanks for having me.
Because it's complicated.
Absolutely.
We're talking way more than just like the internet.
Way beyond.
Yeah.
We're talking the systems that power everything.
Everything. Like what?
Our phones, our power grids, transportation systems, financial networks.
Pretty much everything.
Pretty much everything, yeah.
So to guide us on this journey, we're going to be using this awesome book, How the Network Works.
Excellent reason. It's got tons of great info.
Really brace it down.
And I think it's going to help us really understand just how much these intricate systems we're talking about impact every aspect of our lives.
I think so too, because it's amazing how much we rely on these networks without even realizing it.
Exactly. So where do we even begin with something as complex as this? I mean, it's networks on top of networks on top of...
Right. It can be overwhelming.
Yeah.
It's like trying to explain how a car engine works without even knowing what a piston is,
Right.
And so to really understand how networks function, we need a framework.
Okay.
And that's where the OSI model comes in.
The OSI.
OSI, yeah. It stands for Open Systems Interconnection.
Okay.
But don't worry too much about the name.
Yeah.
What's important is it breaks down network communication into 7 distinct layers.
Okay, 7 layers.
7 layers.
Yeah.
Think of it like a decoder ring for understanding how information travels from one point to another.
Okay, I'm intrigued. 7 layers, though.
It's really intimidating.
Yeah, a little bit. Can you help me visualize this?
Absolutely. Imagine sending a letter through the postal system, right?
Okay.
Each layer of the OSI model is like a different stage in that letter's journey.
Okay. I like where this is going.
Yeah.
So the first stop, or I guess the first layer would be...
The physical layer.
Okay.
This is all about the hardware, the actual physical components.
Like what?
So we're talking cables, connectors, radio waves, even light pulses.
Wow.
It's literally the roads and the trucks of the network physically carrying the data.
Okay, so the physical layer is making sure the message can actually travel.
Exactly. And this is also where we encounter something called signal encoding.
Signal encoding.
Yeah, this is how we transform data into signals that can be transmitted over those physical mediums.
Okay, so is that kind of like turning our letter into Morse code?
Perfect analogy. It's how we get those ones and zeros, the language of computers, into a form that can travel down a wire or through the air.
That's really cool.
All right.
Okay, so we've got our message encoded and it's on the road, so to speak.
Right.
What's next?
So now we arrive at the data link layer.
Data link.
Yes. Now this layer is responsible for making sure the data transfer is reliable on a local level,
Local level meaning.
like within a single network segment.
Okay.
So think of it like this. It makes sure your letter gets from your house to the local post office without getting lost.
Gotcha.
And one of the key ways it does this is through M addresses.
MAD addresses. Like the computers.
Exactly. Every device on a network has a unique MAC address, like a hardware fingerprint that identifies it.
Oh, okay, so it's like the return address on our letter.
Exactly. Make sure the data knows where it came from.
Smart.
And the data link layer also handles things like error detection and correction.
So it's like spell check for data.
Exactly. Making sure typos don't corrupt the message.
Very important.
Yeah.
Okay, so he's got our message encoded, it's got a return address, and it's been spell checked.
Right.
So what happens next?
Well, now we need to make sure our letter gets to the right recipient across the entire network.
Okay, so how does it do that?
That's the job of the network layer.
Okay, network layers.
This is like the postal sorting center of the internet.
Okay.
And it uses something called IP addresses.
I've heard of those.
Yeah. IP addresses are like the zip codes of the internet.
So it knows where to send the message.
Exactly. Each device on a network has a unique IP address that tells other devices where to find it.
So it's like the destination address on our letter.
Exactly. And the network layer is also responsible for something called packet segmentation.
Packet segmentation, what's that?
Well, imagine trying to send a giant novel through the mail as one huge package.
Seems like a recipe for disaster.
It would be a nightmare, so instead we break it down into smaller packets.
Like sending it page by page?
Exactly. Each packet gets its own IP header with the source and destination address, and then they all get sent out across the network independently.
So even if one packet gets lost or delayed, The rest can still make it through.
Exactly. And the receiving device can reassemble them in the correct order.
So it's like a puzzle.
It is a
Yeah.
digital puzzle.
Very cool. Okay, so the network layer makes sure a message is packaged and addressed correctly.
It does.
But how do we make sure all those packets actually arrive at the destination in the right order and without any damage?
That's where the transport layer comes in.
Okay, transfer layer.
This layer is all about end-to-end communication, ensuring that data gets delivered reliably and in the correct sequence.
Okay.
So it's like the Postal Service itself, making sure all those individual pages of our novel arrive at the reader's house in the right order and without any pages getting lost or ripped.
This is where it gets interesting for me because I know there are different ways to send things. Like sometimes we prioritize speed and other times we prioritize reliability. Does that come into play here?
It absolutely. At this layer, we have different protocols that handle data transmission in different ways.
Okay.
The two most common protocols are TCP and UDP.
I've heard of those, but I don't really know the difference.
So think of TCP like registered mail. It's very reliable with error checking and retransmission to make absolutely sure the data arrives safely, but it's a bit slower because of all those extra steps.
Gotcha. So what about UDP?
UDP is like sending a postcard.
Okay.
It's faster and more lightweight because it doesn't have all those error checking mechanisms, but there's no guarantee that the data will actually arrive.
So it's a trade-off.
Exactly. Speed versus reliability.
So like video streaming would probably use UDP where a little lag isn't a big deal.
You got it. While something like online banking would definitely need the security and reliability of TCP.
Makes sense. Okay, so we've moved our message through the physical data link network and transport layers.
We're cruising right along.
What's next?
Now we come to the session layer.
Okay, session layer.
This layer is responsible for managing the connections between devices.
Connections meaning.
Think of it like setting up a phone call.
Okay.
The session layer establishes the connection, keeps it synchronized, and knows when to terminate the connection.
So it's like making sure the communication channels are open and flowing smoothly. Exactly. It's the traffic cop of the network, making sure everyone is talking to the right people. That makes sense. And what about the presentation layer? What does that do?
The presentation layer, this one deals with data formatting and translation.
Translation like languages.
Not exactly, but it's a good analogy.
Mm-hmm.
It ensures that data is presented in a way that the receiving application can understand.
So is it kind of like making sure a document created on a Mac can be opened on a Windows PC?
Exactly. It handles things like file formats, encryption, and data compression.
So it's like the universal translator of the network.
Exactly, making sure different systems can talk to each other without any misunderstanding.
That's amazing. Okay, so we've encoded, addressed, routed, packaged, and translated our data.
We're almost there.
What's the final stop?
Finally, we arrive at the application layer.
Okay, application layer.
This is the layer that we as users interact with directly.
Okay,
This is where all the fun stuff happens.
like what?
Email, web browsing, video conferencing, online gaming, all these applications operate at this layer.
So it's like the storefront of the network.
Perfect analogy. It's where we get to see and use all the services that the network provides.
Wow, it's amazing to think about all those layers working together every time we send an email or stream a video.
It really is a symphony of technology, isn't it?
It is, and I'm starting to see why it's so important to understand how these layers work.
Absolutely. And keep in mind, this is just a basic overview.
Right.
There's so much more to explore, but having this framework, the OSI model, helps us make sense of this complex world.
Totally, it's like having a map when you're exploring a new city.
Exactly. And as technology continues to evolve, understanding these fundamental principles will become even more important.
I think you're right, especially with things like the Internet of Things becoming more and more prevalent.
Oh, absolutely. Think about it. Smart homes, self-driving cars, interconnected devices, all these things rely on networks to function.
And all those networks rely on these 7 layers we've been talking about.
Precisely. And the demands on these layers are only going to increase as our reliance on these technologies grows.
So knowing even the basics empowers us to navigate this digital landscape more effectively.
I completely agree. It helps us understand how things work, why things sometimes go wrong, and what the potential is for the future.
That's a great point. So next time I'm waiting for a website to load or dealing with a dropped call, maybe I'll feel a little less frustrated and a little more appreciative of the invisible network working behind the scenes.
I think that's a great takeaway. Understanding the network, even just a little bit, can really change your perspective.
It definitely has for me. So to everyone listening, I encourage you to think about the network next time you're online.
Yeah? Pay attention to those loading icons, those buffering messages, those little hiccups.
Because behind those seemingly minor inconveniences,
Lies a complex and fascinating world that's constantly working to connect us all.
a world that's only going to become more intricate and more crucial to our lives as we move forward.
Exactly. And who knows, maybe understanding these basic principles today will inspire some of you to become the network engineers and innovators of tomorrow.
That's a great thought. Thanks for joining me on this deep dive. I'm feeling a lot more informed and a lot more curious about the hidden world of networks.
It's been my pleasure. And remember, the OSI model is your friend.
I'll keep that in mind. To everyone listening, thanks for tuning in, and we'll see you next time for another deep dive into the world of tech.
See you then.